Welcome. As you can see, this is Flappy Bird, the original version. In this game, you will control a bird to avoid the pillars. And by avoiding those pillars, you will get score and proceed in the game. And as the score gets higher, the game speed increases as well, which makes the game more difficult and challenging. And this is my game. I built it from scratch by implementing all the interesting functionalities of the original Flappy Bird. So, as you can see, the bird is doing well, moving to avoid the pillars, because otherwise he will just die. Are you ready to see how we could make such a game using Python? Then, let's begin. To organize my ideas, I use this beautiful tool to schedule the tasks that I have to do in order to create the game. So, the first thing I had to do is to download the assets, and then make the game window, and of course include all the assets in the game. And finally, animate the background. So, after a while in the internet, I could download all the assets. So, the game window actually wasn't really that difficult. I had to import just by game and make a black screen with specific dimensions. And also, I had to define the time between each frame. It's also called the simple time, and I chose it to be 60 milliseconds. This is the first result. It was a mere black screen. Let's move to initiate the background. To replace the black screen with Flappy Bird background, I took the background image that I already downloaded and displayed it in the screen. But regarding the width of the window, I duplicated the image in time in order to fill all the screen. Okay, this is the result as you can see. Let's move to the other step. To animate the background, I created a variable speed, and in each frame I shifted the background images to the left by a step equal to that speed. Actually, that shift caused this empty space that I filled with new images. Regarding the time we choose between each frame, the human eyes will see an animated screen. And that was our goal. Okay, this is the animated background. Now let's move to the serious things. The first thing, we will create an animated bird. Then we will create moving pillars, and we will allow the bird to move. We will edit some collisions and allow again the bird to die. Added score and added sound effects, and finally the game over screen. Let's get down to business. In this part, I took the bird images and displayed them consecutively in order to make a flying bird. To make the moving pillars, I created some variables in order to fix the distance between two consecutive pillars. To also fix the height of the gap between the top and the bottom pillar. Then I made a short script to generate the pillars and move them with a specific step equal to the speed of the game. So, to make the game unpredictable, when I generated those pillars, I generated them with random positions. And as you can see, this is the result of the moving pillars. To render the bird able to move, we assume there are three forces. One force pushes the bird up, while the other one pushes him down. These two forces emerge just when the player presses space or down. In the opposite, the third force is permanent. We can call it gravity. So, to control the bird with those forces, we use some common physics foundations. Newton's laws precisely. As you know, the second law of Newton says that the sum of the external forces is equal to the mass multiplied by the acceleration. So, at the first time we initiated the two forces by zero, and we only give them a positive value when the player hits space or down. So after that, we started to implement Newton's law in Python by using differences. So instead of acceleration, we can put, for example, actual velocity minus the last velocity divided by the simple time. And because the simple time was in millisecond, we used 10 power minus 3 to transform it into seconds. And as you can see, this is the result. The bird cannot collide with the pillars because we didn't implement this yet. For collisions, I verified if the bird's scope is touching the pillar's scope. And I made this by using collide method of the rectangular object provided by Pygame. For the bug reason, I displayed the message to see if the concerned script worked well. And as you can see, when the bird's scope matches with one of the pillars, a message is displayed. Afterward, this message will be changed by die function. Okay, let's make a score. To make one for the game, I made a method to check the bird position and sees if it's between the pillars. If that's true, I incremented the variable and then displayed it in the game. Finally, we arrived to the exciting part, the sound effects. As you know, without sound effects, the game cannot be enjoyable. So, in this part, I managed to download some SFX. This one for the normal fly. This one for the sprint. This when we get score. And this when the bird hit the ground or one of the pillars. For the implementation, I used a dictionary to write down all the sound paths. Then, I created a variable for each sound to use them afterward within the code. When I needed a sound, I just used the method play in the place that I wanted. Unfortunately, the things didn't go as I expected. The sounds were not synchronized properly, and even sometimes they don't play. Just in this case, the score sound sometimes play and sometimes not, which is wrong, so I had to deal with this problem. Also, the crash sound didn't play. I still don't understand why the sound is not playing, although it's correctly called, so I will take a while to do some analysis.
A few moments later.
I'm still stuck here, guys, but don't worry, I made some progress. See you soon.
2,000 years later.
To understand how sounds are working in Pygame, I thought maybe I need to check its documentation. And there I found something that mattered. As you can see here, the play method has something really special. So they mentioned that by playing a new sound, the last sound will be cut off. It's like overriding the buffer, so I started to think to look for another method to play sounds separately, and there I found something called channel. This will allow you to play sounds in a separate way, and dramatically this was the solution of our problem. So we moved directly to the implementation. At this level we created a vector of channel for each sound. And then we created a method to play the sound in its specific channel. And finally, we got a good result. The sounds are now synchronized and working well. Okay guys, after finishing the game, let's see the game and enjoy it.